What's up, my favorite humans? Miss Sorensen here with video 3. So for this topic here, we are going to be discussing dominant strategy in two-choice games. So I think we should just get right to it. Don't forget, we're going to revisit the prisoner's dilemma when it comes to two-choice games. So if we were in class, what we would have done is I would have given you what they call a payout chart. And I would have asked you to play this 10 rounds with the partner and then calculate your earnings at the end. Let's look and see what this means. So there's two people playing this, and one person would be Pepsi. They'd be the Pepsi company. And they would be able to choose two options. They could advertise their company, advertise that Pepsi's the best, or they could not advertise at all. So they've got two choices to make. The other person, your partner, would have been Coca-Cola. So here's Coca-Cola right here, Coke. They would have also chosen to advertise or to not advertise. They've got two choices as well. Well, if you both chose to advertise, this $25, it's probably represented in thousands, like 25,000, but let's just say $25 for now. So if they advertise, Pepsi would have made, see the P under here? This number here, 25 that I boxed, always has to do with the first column, this thing on the left here. So if Pepsi chose to advertise and Coke chose to advertise, then Pepsi would have made this $25 right here, and Coke would have made this $25. However, if they both chose to not advertise, Pepsi chose don't advertise, and Coke chose don't advertise, they would have ended up with $50 for Pepsi and $50 for Coke. It's kind of like their revenue or their profit, if you will. But let's say that Pepsi chose don't advertise and Coca-Cola chose advertise. In this case, because Pepsi chose not to advertise, they get $0, and Coke did advertise, so they get $60. So it kind of gets screwed. They kind of get screwed over. It's kind of just like the prisoner's dilemma, is it not? And then the last situation is, what if Pepsi chose advertise and Coke chose don't advertise? Well, here, Pepsi's going to do really well because they advertised and Coke did not advertise, so Coke gets $0. Now keep in mind that this is game theory, meaning that these are rational opponents who want what's best for them, and they're making these choices at the same time. Of course, if Coke chose to not advertise and Pepsi knew that, they would have said, oh, let's advertise. But that's not the situation here. They don't know what the other person is going to do. That's what makes this tricky. So let's talk about how to find a dominant strategy. A dominant strategy is a strategy that is best for you regardless of what the other player does. Okay, so let's find the dominant strategy of Pepsi. So what we need to do is look at the two situations. And those two situations are what Coke does. So in order to figure out what the dominant strategy is for Pepsi, we have to assume that Coke can do either thing. The first thing that Coke can do is advertise. So if Coke advertises, what is the best thing for Pepsi? Well, let's look at the two situations. Remember, Pepsi is going to be the first number. So if Coca-Cola advertises, Pepsi would make $25 by choosing advertise, and they'd make $0 by choosing don't advertise. Which one is better for Pepsi if Coke chooses advertise? Well, it's going to be best for Pepsi to advertise, right? Because $25 is better than $0. So I want to put a check next to advertise. That means that if Coke advertises, if Coke chooses this situation right here, it is best for Pepsi to advertise. Well, that's not the only situation. The other situation is that Coca-Cola could have chosen to not advertise. Now, in this situation where Coke chooses to not advertise, what should Pepsi do? Well, again, we're going to look at these first numbers. We could either choose to advertise or to not advertise. So again, if Coke chooses don't advertise, which one looks better for Pepsi, the $60 or the $50? Well, of course, the $60 is better. So in this case, it would be better for Pepsi to advertise. So you can see here that in both situations, it does not matter if Coke chooses advertise or don't advertise. In both situations, Pepsi's best strategy is to advertise. So that is Pepsi's dominant strategy. Okay, so our answer here is Pepsi dominant strategy is advertise. Okay. Now let's go ahead and let's find the dominant strategy for Coca-Cola. So we have to consider the two situations. Here, if Pepsi chooses to advertise, here we're looking at comparing $25 versus $0. Well, clearly $25 is better for Coke, so if Pepsi chooses to advertise, then Coke wants to advertise as well. Okay, now let's look at Pepsi doing the other option, and the only other option is for Pepsi to not or don't advertise. Okay, well then for Coca-Cola, the options for them would be to choose the $60 option or the $50 option. And obviously we prefer $60 to $50, so Coke in this case should choose to advertise. So Pepsi, their best strategy or dominant strategy is to advertise, and Coke or Coca-Cola, their best strategy is to advertise as well. And what does that really mean? That means after doing this activity a ton of times, or doing this in real life year after year after year, they're going to end up in this location right here. Oops, excuse me. They're going to end up in this location right here because both of them have a dominant strategy to advertise. $25, $25. And you might say, well, Ms. Sorensen, I kind of get why you originally circled this one because this makes the most sense, $50, $50. That's a lot more than $25, $25. But no, actually, by acting in their own interest, they end up at $25, $25. Okay, let's try another one. What's Bob's dominant strategy? Okay, well, in order to determine Bob's dominant strategy, we have to consider that Alice has two options. Alice, let's say Alice chose to run. Well, in this case, Bob has the option to run or to stop. Which one's better for Bob? In this case, you're right. It's better for Bob to stop because 2 is better than 1. Remember, those higher numbers are better. It's like $2 over $1. So in this case, if Alice chose to run, Bob should choose to stop. Now let's look at the other situation. Let's say that Alice chooses to stop. Let's look at this. Which one's better for Bob, -1 or a 2? Well, obviously 2. So in this case, Bob should stop as well. So Bob's best strategy would be to stop. Because in both situations, regardless of what the other player does, the better situation would have been for them to stop. Okay, what value needs to be placed in for A in order for player 1 to have a dominant strategy? Well, let's first figure out what the dominant strategy could possibly be. So in this situation, let's say that player 2 chooses D. Okay, well, what's better for player 1? Either $0 or $1. So here, if player 2 chose D, the B is the better option to choose because 1 is bigger than 0. Now let's say that player 2 instead chose C. Well, we are comparing 3 and A. And since there's already a check mark here, in order to have a dominant strategy, you need 2 check marks. So we would need this A to be 3 or bigger. It's okay if there's a tie if one of the other sections beats the other. So in this case, A has to be greater than or equal to 3 in order for B to be the dominant strategy. There's no possible way that A could be the dominant strategy because it fails when player 2 chooses option D. Is there a dominant strategy for the prisoner's dilemma? Well, let's look. Let's first find the dominant strategy for Miss Red. So for Miss Red, let's say that blue chooses to cooperate. What's better for Miss Red? 1 year in prison or 0 years in prison? Well, 0 years in prison is better, so we're going to say that defect is better if blue chooses to cooperate. However, what if blue or Mr. Blue chooses to defect, meaning chooses to tattletale on her? Well, she can either take 3 years in prison or 2 years in prison. Which one does she prefer? Obviously 2 years in prison. So for Miss Red, the dominant strategy is going to be to defect. So defect for Miss Red. Let's see if that's true for Mr. Blue. So let's say that for Mr. Blue, we assume first that Red decides to cooperate. Well, here, Blue has the option of getting 1 year in prison or 0 years in prison. So if Miss Red cooperates and doesn't say anything, he's much better off defecting or tattletaling on her. So I'm going to put a check next to defect. But what about the other situation? What about the situation where she does tattletale? Well, in that situation, he's got an option between 3 years in prison or 2 years in prison. And he clearly prefers 2 years in prison. So again, in the situation where Miss Red defects, Mr. Blue wants to defect as well. So in this situation as well, Mr. Blue, he also wants to defect. That's his dominant strategy. So if both of those people have a dominant strategy of defecting, their game is going to end up right there, meaning they're both going to get 2 years in prison. You might want to pause the video and try this one on your own. This one's about advertising. Okay, so hopefully you tried this one on your own, and let's see what you got for an answer. So we've got 2 cigarette companies trying to figure out if they want to advertise. And this is the Red Strides company. And this is the Smooth Blue. Smooth Blue. All right. So let's go with Red Strides first. Let's say that we're trying to find the dominant strategy for Red Strides. Well, for Red Strides, let's say that Smooth Blue decides to not advertise. What's better for Red Strides? To either not advertise, that's what that cross means there, or to advertise. Well, clearly it looks better. 130 is better, so Red Strides would prefer to advertise if Smooth Blue chose to not advertise. Now, what's our other situation? Our other situation is that Smooth Blue does choose to advertise. So Red Strides is left with either not advertising and getting 40 or advertising and getting 70. Well, clearly 70 is better than 40, so we put a check mark here. So for Red Strides, the best dominant strategy would be to advertise. Okay, let's find the same thing for Smooth Blue. Well, for Smooth Blue, we have to consider the 2 options that the Red Stride would choose, and the first option would be that they don't advertise. And in that case, we're either getting $100 for Smooth Blue if they don't advertise, or $130 if they do advertise. Well, clearly we want to advertise in this case. But what about the other option? What if Red Strides chooses to advertise? Well, then Smooth Blue is either left with $40 or $70. In this case, 70 is better, which is the category of advertising. So again, Smooth Blue wants to advertise as well. And they would be left in this game. If they both played this game for many, many years, where would they end up? They would end up being right here at $70 each, because that's their dominant strategy for both teams. All right, determine if each firm has a dominant strategy. Okay, well, let's take a look at firm 1. Here I'm going to circle that firm 2 chose this. So what should firm 1 decide, $15 or $25? Oh, firm 1 should choose low, because 25 is bigger than 15. What if firm 2 chose low? We're between $0 and $5, so 5 is better. So for firm 1, the dominant strategy would be low. Now let's find the dominant strategy for firm 2. Okay, in this situation, let's assume that firm 1 chooses high. What's better, 15 or 25? Well, obviously 25 is better, so low for them. What if firm 1 chose low, though? We're between $5 and $0. Well, low is better for them as well. So firm 1 and firm 2, they would be at low. And here in this situation, you'd be left at 5.5. And don't think that always the answer is down in the bottom right corner. That's not the case. It's more typical than not, but it's not necessarily the case. So I want to go back to the prisoner's dilemma. This is huge. I would say that this is the most important slide out of any that I've done so far. This is connecting right now the prisoner's dilemma with dominant strategy. Okay, this is the last slide we're doing, and it's super important. I want you to remember where we ended up for all 4 of these situations. We ended up here, and we ended up here, we ended up here, and we ended up here. Now, the prisoner's dilemma is the dilemma where people are actually hurting themselves while thinking about themselves. So remember, by red acting in their best interest, and no matter what case blue did, it was better for red to defect or tattletale. Remember, regardless of what red did, it was better for blue to defect or tattletale, regardless of what red did. So they're basically thinking about their best interest, but isn't it interesting that when they're thinking about their best interest, they end up hurting each other? Because they could have both cooperated and been nice to each other and both gotten 1 year in prison. Same thing is true for this advertising situation. By thinking about themselves and trying to do what's best for themselves, they actually end up hurting themselves when they could have ended up making $30 more by both choosing to not advertise. Same thing in this situation here. If they had both chosen to not advertise, they would have made twice as much money if they ended up here. And same thing here. This 5,5 is not even close to the best situation. The best situation would have been here. So this is a huge model in business showing that although competition is really good and drives our economy, sometimes the ability to not think about yourself and to think about others and to cooperate would actually end you in a place that was much more beneficial for everyone, right? We're talking about making $10 more here, $30 more here, making twice as much money here, and having 1 less year of prison here. It's a very, very interesting philosophy that makes you think about much broader things in the world, about how cooperating can actually help you and others, as opposed to just thinking about yourself and doing what's best for yourself. All right, thanks for listening.